Crane Safety Operations Training. Crane operations are inherently high-risk activities and, therefore, as a project supervisor, you must do everything possible to ensure the safety of your workers and others present at the job site during crane operations. Especially for those working around the hook, the safety risks are even greater. If the suspended load drops or moves under the influence of the weather, chances for an accident become more likely. Cranes are tremendously powerful pieces of equipment that make it possible to lift heavy loads on construction sites. That said, cranes are also potential hazards, as both cranes themselves and the loads they carry can cause harm when improperly handled. Crane accidents take a heavy and tragic toll each year in lives, serious injury, and/or property damage. The vast majority of crane accidents are the result of personnel error and in many cases can be avoided. Many of these incidents involve in construction. From driving sheet piling for a simple bulkhead or seawall from land, piling for a dock structure, or more hazardous yet, a crane mounted on a barge, working on a bridge project, cofferdam or other on-water structure. Crane operation safety is the result of effective teamwork among operators, riggers, and crane walkers. In most accidents, a team member either performs an unsafe action or fails to perform a required safe action. In a vast majority of cases where team personnel are at fault, it is due to inattention, poor judgment, overconfidence, or haste to get the job done. The following brief writing prescribes basic crane safety procedures that every crane team member and/or operator may just want to thoroughly understand and constantly practice to avoid a potential accident. Introduction. The purpose of this class is to provide you with an overall foundation of knowledge pertaining to cranes and crane safety. Upon completion of this course, students will be able to identify types of cranes and their basic components, recognize hazards associated with cranes, and understand safe operating practices. A crane is a machine for lifting and lowering a load and moving it horizontally, with the hoisting mechanism an integral part of the machine. Cranes, whether fixed or mobile, are driven manually or by power. More about crane terminology, go through the image. Course overview. 1. General rigging safety. 2. Types of cranes. 3. Types of slings. 4. Types of hazards. 5. Daily operations instructions. 6. Operations safety. 7. Hand signal. Chapter 1 is General Rigging Safety. What we will cover in this chapter. 1. General safety practices. 2. Inspection requirements. 3. Proper identification of equipment limits. 4. Proper storage of equipment. 5. Hitches and slings. Brushes. Bridle hitches connect two 4-sling legs to a load via lifting attachments, for example, lugs. Safe practices. 1. Make sure the load is balanced by placing the hook point over its center of gravity and adjusting the leg lengths to keep the load level. 2. Prior to connecting to your load, determine the working load limit for multi-legged slings. 3. If using a 4-legged sling, calculate the working load limit as you would if only using 3 legs. This allows the load's weight to be evenly distributed while also leaving a leg free for vertical and choker hitches. Under normal conditions, a sling in a vertical, 90 degrees, hitch will be able to lift its maximum rated capacity. Choker hitches will tighten on a load when lifted, but will not provide full 360 contact with the load unless the line is wrapped around the load twice, creating a double choker hitch. Additionally, the capacity of a sling in a choker hitch is 75–80% of the sling's maximum rated capacity. Safe use. Do not use a choker hitch to lift loose bundles. Do not use slings made with wire rope clips in a choker hitch. Do not use wire rope slings with ferrules in choker hitches. If using a hitch where the angle of choke is less than 120, make sure to adjust the sling's capacity accordingly. Basket hitches. Basket hitches allow loads to be easily controlled. They minimize a load's tendency to twist. Basket hitches can either be connected to a single hook or in a U configuration with each leg connected vertically to a spreader bar. The vertical U configuration allows the sling to carry the full rated capacity on each leg, as long as the DD ratio is at least 25:1. Safe use. Do not use basket hitches on hard-to-balance, environmental conditions. Be aware of environmental conditions that may affect the capacity of the sling or other components. 1. Weather. Wind. Precipitation. Temperature. Visibility. 2. Worksite features. Power lines or other overhead obstructions. Uneven or unstable surfaces. 3. Reactive substances. Chemicals which may damage slings, other rigging components, or Chapter 2 is types of crane. A crane is a machine for lifting and lowering a load and moving it horizontally, with the hoisting mechanism an integral part of the machine. Cranes, whether fixed or mobile, are driven manually or by power. Generally, cranes are following types. 1. Mobile crane. 2. Gantry crane. 3. Tower crane. 4. Mechanical crane. Lifting of cranes are manual lifting, mechanical lifting. Mobile crane, see Mobile crane safety checklist. We should inspect crane as per displayed checklist. Crane should be inspected by competent person only. Gantry crane, see image. Tower crane, see image. Mechanical crane. A crane is a type of machine, generally equipped with a hoist rope, wire ropes or chains, and sheaves, that can be used both to lift and lower materials and to move them horizontally. The device uses one or more simple machines to create mechanical advantage and thus move loads beyond the normal capability. Crane-related accidents. 14,000 workers killed on the job every year across world. 38 fatalities on every day across world. Cause of deaths. 1. Overhead power line electrocution. 2. Crane collapse. 3. Struck by crane booms, jibs. 4. Struck by crane loads. 5. Caught in between. 6. Struck by cranes. 7. Wrong rigging practice. 3 is types of slings. A. Alloy steel chain. B. Wire rope. C. Metal mesh. D. Fiber rope. E. Synthetic. Others tools of cranes are A. Lifting ring. B. Lifting hook. C. Lifting shackle. D. Lifting swivel. E. Eye bolt. F. Lifting cage. Slings and tools. Visual inspections. Replacement of wire rope slings. Replace if any of the following conditions occur. A. Broken wire. B. 10 randomly distributed broken wires in a lay length. Circa 5 broken wires in one strand of one lay length. D. 1 or more broken wires within lay length to an end fitting. E. Kinking. Replace if any of the following conditions occur. A. Crushed or flattened wire rope. B. Broken core. C. Bird cages. D. Tension breaks from overloading. E. Corrosion. F. Heat damage. G. Abrasion. Replacement of chain slings. Replace if any of the following conditions occur. A. The chain is not grade 8 or 10 alloy. B. More than 10% wear. C. Nicks, cracks, breaks. D. Stretching or bending. E. Extreme temperatures. F. Improper functioning of hardware. G. Missing or illegible tag. Replace if any of the following conditions occur. A. Significant cuts, tears, and abrasions. B. Red core fiber is exposed. C. Heat damage. D. Busted stitches. E. Illegible identification. F. Chemical or UV exposure. G. Knots of any kind. Chapter 4 Types of Hazards. Hazards in crane operations. A. Power line contact. B. Rigging failure. C. Structure failure. D. Tip over. E. Swing radius crushing. Cause of crane failure. A. Improper setup. B. Do not know the lifting weight. C. Untrained crane operator. D. Non-appropriate physical conditions of crane and its equipment. E. Overload of crane. Chapter 5 is daily operators inspections requirements. A. Daily inspections should be performed at the beginning of each shift or before initial use of the crane each shift by the operator or appointed person. B. Make sure crane or hoist is not tagged out. If a tag is in place, it is usually located at the power disconnect to the runway or on the push-button station. C. Check the hook block to make sure all sheaves are running freely and sheave covers, guards are in place. D. Inspect the hook for the following. Is the safety latch in place? Does it operate correctly? Check the rotation of the hook. Does it rotate freely the whole 360 degrees? 1. Inspect the wire rope to make sure it is lubricated and that none of the following conditions exist. A. No kinks. B. No broken or cut strands. C. No corrosion. D. No crushed sections of rope. 2. Inspect the control device to make sure all warning labels are in place and there are no cracks or missing bolts in the case. Daily operators inspections requirements. A. Tagged crane or hoist. B. Control devices. C. Brakes. D. Hook. E. Hook latch. F. Reeving. G. Limit switches. H. Oil leakage. I. Unusual sound. Daily visuals checks. A. Oil leakage. B. Motion indicators. C. Hoist limit switches, travel limit switches and indicating devices. D. Check hook block. E. Check wire ropes. F. Check shackles for any defects. G. Check web slings conditions. Chapter 6 is operational safety. 1. Do not overload the crane or hoist. Make sure the combined weight of the lifter and load does not exceed the rated load capacity of the crane or hoist. 2. Refuse to make lift if you are unsure of any issues. Do not proceed until all issues are resolved. 3. Before lifting, ensure that everyone is clear of any pinch or crush zones. 4. Always maintain a clear view of the crane path so you can observe any obstacles or personnel in your path. 5. Do not lift loads over people. Stay out from under the load and make sure other people remain at a distance. 6. Do not become distracted while traveling. If you need to speak with someone, cease operation of the crane. 7. Never leave a suspended load unattended. If you must leave the area, lower the load to the ground before doing so. Operational safety. 1. Visually check the operating environment to make sure that there are no new hazards which might affect the safe use of the crane. 2. Do not operate the crane if not feeling well. 3. Do not lift a load from the side. Center the crane directly over the load before hoisting to avoid swinging the load. 4. Do not operate the crane if it is locked out or tagged out, LOTO. 5. Do not ride on the load or allow others to do so. 6. Do not lift loads over people. 7. Do not use the hoist rope, chain as a. 8. Do not overload crane or hoist. 9. Do not multitask when operating the crane. Don't talk on phone and anyone while operating crane. 10. Do not operate the crane in a rushed manner. Slowly operate. 11. Do not leave suspended load overnight or unattended. 12. Do not use crane to pull out a jammed or stuck object. 13. Use tag lines or push-pull sticks to help control the load. 14. Communicate clearly between lifting team before and during lift. 15. Make sure the load is properly secured before lifting. Chapter 7 Hand Signals. Standards hand signals as per displayed image.
It is a normal morning on the platform, but something unexpected is about to happen. A filter needs to be changed in the pump room. It is a purely routine task, and the operator knows exactly how he is going to tackle the job. There are some barrels in front of the new filter which block the way, and the monorail ends up being too short for this lifting operation. The operator lifts the old filter and runs the block as far as it will go to the end of the monorail. To get past the barrels, he has to find an ad hoc solution. In order to set down the filter, the operator pulls the chain down to the side of the monorail. As he is about to fasten the new filter to the chain, it happens. The stopper, bracket, shackle and bolts fall to the ground right beside the operator. Fortunately, the operator comes out of the accident with only a scare and no injuries. Before we go on to look at this incident in more detail, think about a situation where you have used equipment that was not designed or properly dimensioned for the job. In order for us to fully understand why this operation ends in such a dangerous situation, we need to take a closer look at several critical conditions. The direct cause of the accident was a weakness in the stopper on the monorail, which breaks under the strain of the lift. Upon closer inspection, it was revealed that the bolts used to fasten it were not dimensioned for such a load. The barrels placed in front of the filter made this a poorly organized workplace, and the operator could not perform his job the way he was supposed to. In addition, the monorail was not long enough for this operation, which resulted in extra strain. There were no procedures for this job because changing filters happens so often it is considered a purely routine job. When the accident is investigated further, it comes to light that the operator did not have adequate competence to perform that kind of lifting operation. Analyzing a job, recognizing hazard dangers, and having respect for safety are important aspects of what it means to have competence. Performing a job without proper competence is dangerous. Could the operator have had the barrels moved or done something else in this situation? What do you consider a routine job? Is a routine job risk-free? What do you think about how the operator evaluated risk in this situation? How can we avoid this kind of incident? In this instance, management needs to initiate a series of measures in order to correct the critical conditions that were revealed by the investigation. All of the monorails on the platform shall be inspected to ensure that, among other things, the bolts are properly dimensioned. Personnel performing lifting operations shall receive training. Management and supervisors shall review competency requirements for monorail operators. New routines for inspecting and preparing work areas shall be developed. Using the monorail shall be included as part of job planning. Do you have any more suggestions for how to prevent similar incidents? Many accidents happen when we least expect it, and routine jobs without specific procedures require extra caution and care. When a job becomes routine, we can forget to think about what we are really doing. Could this have happened where you work? What will you do to ensure that a similar situation does not occur where you work? Our work is never so important or so urgent that we don't have time to do it safely.